let's look at some cases where we have to remember what the integral form of the gamma function looks like, so we can use it to our advantage. Let's look at the problem that asks us to express a given integral in terms of the gamma function. So we can have, again, not the numerical approximation of the integral, but exact value of that integral, even if it means it has to be in terms of the gamma function. So let's look at the integral from 0 to infinity of minus e to the power of minus x to the fourth dx. No minus sign, excuse me. Looking at this integral, if you don't know the definition of the gamma function, you're not gonna go far. That's why I told you before that it really helps to know how these look like in the integral form. And if you look at this, and if you look at these formulas here, you can see that that is very similar to either this one or that one. So let's try and use maybe like this form, and try to bring this integral into something that looks like this. So what we notice here, if I write side by side the integral that we are after, so we have here e to the some power e to the power of minus x to the fourth, which is similar to this, except that our x is has to have the power of 1, and we have power of 4. So that can be easily taken care of by substituting x to the fourth, replacing it with some u, let's say dummy variable u. And we are also missing a factor of x here. I guess we'll have to see if we get it somehow, but let's do this first. Let's assume our x to the fourth is our u, and so if we now have the variable u here, we have to make sure that our dx is also in terms of du, so we can actually perform the integral. So du is then 4x to the third dx, and look at this, we've got our x to some power, just as we have here. Yeah, so I think we're heading in the right direction. Okay, so now we have our dx. Oh, but notice our x in here is still an x, and it needs to be in u. So we have to have x in terms of u, and we can get it from here. So x is u to the power of 1/4. So now we are ready to substitute, and we can get an expression like this. So our e to the power of minus u, and our dx is now 1/4. X is u to the 1/4. And cubed du. So to simplify this expression, so let's take 1/4 out. Integral 0 to infinity, and then we have u to the power of minus 3/4 e to the power of minus u du. Now this looks pretty much like this. It's the same thing. This part is our g of p. G of p. But we have to find the value of p, because we don't know. I mean, it can be easily read from here, but yeah, remember our main task was to express this integral in terms of function gamma. So if our p minus 1 equals minus 3/4, then our value of p is 1/4. And so that's our p, and our integral becomes 1/4 gamma of 1/4. And that's our final answer.